Let's launch into coroutines. When this Start button is pressed, we want to call a function in our Sleep Tracker view model that creates a new instance of Sleep Night and stores it in the database. Here is our very empty Sleep Tracker view model. Let's go and add the code we need for implementing the click handler for the Start button. We are going to use coroutines because, among other things, clicking the buttons triggers database operations, such as creating or updating a sleep night, and we don't want that to slow down our user interface. To manage all our coroutines, we need a job. This view model job allows us to cancel all coroutines started by this view model when the view model is no longer used and destroyed, so that we don't end up with coroutines that have nowhere to return to. When the view model is destroyed, onCleared is called. We can override this method to cancel all coroutines started from the view model. Let's put it at the end of the class. And we tell the job to cancel all coroutines. Next, we need a scope for our coroutines to run in. The scope determines what thread the coroutine will run on, and it also needs to know about the job. To get a scope, we ask for an instance of coroutine scope, and we pass in a dispatcher and a job. Our dispatcher here is dispatchers.main. This means coroutines launched in the UI scope will run on the main thread. This is sensible for many coroutines started by a view model, as they will eventually result in an update of the UI after performing some processing. And we pass view model job as the job. We need a couple more things. We need a variable to hold the current night. Let's call it tonight. We make this live data because we want to be able to observe it, mutable live data, so that we can change it. We also want to get all the nights in the database when we create the view model. We defined getAllNights to return live data in the sleep database DAO. And Room will take care of keeping this live data updated if anything changes. We need to night set as soon as possible so we can work with it. So we do that in an init block, where we call a function initializeTonight. Here is the signature for initializeTonight. Inside, we are using a coroutine to get tonight from the database so that we are not blocking the UI while waiting for the result. So our code does the following. We need to specify the scope, UI scope. And in that scope, we launch a coroutine. Launching a coroutine creates the coroutine without blocking the current thread in the context defined by the scope. Unless you specify otherwise, the coroutine is scheduled to execute immediately. And the work we want done is to get the value for tonight from the database by calling getTonightFromDatabase. Now, we want to make sure that getTonightFromDatabase does not block. And we want to return a sleep night or null. The function can be private. We mark it as suspend because we want to call it from inside the coroutine and not block. And we want to return a sleep night or null. Okay, how do we get that sleep night to return? We actually create another coroutine in the IO context using the IO dispatcher and call database getTonight from the DAO. This returns the latest night saved in the database. If the start time and end time are the same, then we know that we are continuing with an existing night. For example, if the user started the app, then closed it and went to sleep, and restarts it in the morning. If the start time and end time are not the same, then we have no night started, and so we return null. And we need to return the night. So now we can implement our click handler for the Start button. What we want to happen here is we want to create a new sleep night, we want to insert it into the database, and we want to assign it to tonight. We call the function onStartTracking, and its structure is going to look very much like initializeTonight. Inside this function, we launch a coroutine because everything that happens from here on will be time-consuming, especially the database operation. Again, we do this in the UI scope because we need this result to continue and update the UI. We create a new sleep night, which captures the current time as the start time. Then we call insert to insert it into the database, which is going to be our suspend function for the database operation. Finally, we set tonight to the new night by calling getTonight from database. So now let's define insert, which is going to look very much like getTonight from database. It's a suspend function. We use dispatcher.io and then call the DAO method insert. So now we can see a pattern here. Let me drop that here real quick. So here is the pattern. We launch a coroutine that runs on the main or UI thread because the result affects the UI. Inside, we call a suspend function to do the long-running work so that we don't block the UI thread while waiting for the result. We then define the suspend function. The long-running work has nothing to do with the UI, so we switch to the I/O context so that we can run in a thread pool that is optimized and set aside for these kinds of operations. And then we call the database function to do the work. All right, let's create the other two click handlers, one for the stop button and one for the clear button. Here is on stop tracking, and it follows our coroutine pattern. Notice the return annotation. In Kotlin, the return at label syntax is used for specifying which function among several nested ones this statement returns from. In this case, we are specifying to return from launch, not the lambda. We update the end time to be the current time and call update to update the database. Here is update, exactly looking like insert, which is nice. And here is onClear, along with clear. Now, in the XML layout, how do we connect onStart tracking to our start button? With the magic of data binding that we set up earlier, we can now add a click handler to the start button. It looks like this. What this means is we are adding a lambda function that takes no arguments and calls the onStart tracking function in the sleep tracker view model. And this funky notation here creates a lambda. We can also add the click handlers for the stop and clear buttons. Okay, now let's go on and display our data so we can see what's important, whether we got any sleep.